All right, well, 30, 60, 90 triangles, 45, 45, 90 triangles, and the Pythagorean theorem are all great ways to find side lengths of triangles. But what if you know one length and one angle? Then we won't be able to use the Pythagorean theorem, and you can only use your special triangles if they are in fact special triangles. So there's another way that you can solve triangles, and that's to use what's called right triangle trig. So I'm just going to draw this out here from your notes so we can kind of go through what that is. So again, you have to have a right triangle. Remember, all of these are talking about right triangles. And now in this case, it doesn't matter what the angle is, but it does matter where you're looking at the angle. So there's three trig ratios. The first one is called the sine, and the sine is defined as the opposite side over the hypotenuse. And so you always have to know what angle you're looking at. So if this is the angle I'm looking at, the side that's opposite this one will be the side that's furthest away, which would be over here. So this would be the opposite side. And then the hypotenuse is always opposite the 90. That never changes. And then the other side we have is the one that's right next to the angle we're looking at. We're going to call that adjacent. So the sine of some angle is always defined as the opposite over the hypotenuse. And we'll get into how we use this in just a minute. The cosine of some angle is defined as the adjacent over the hypotenuse. And the tangent is defined as the opposite over the adjacent. So the opposite angle over the adjacent angle. Side, the opposite side over the adjacent side, sorry. Now, there's some way that you can use to kind of remember these, and that's called SOHCAHTOA. Maybe you've heard people talk about that. SOHCAHTOA, and what that stands for is the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So this is kind of a way that students help themselves remember what these trig ratios are. So let's just take a look at it. Now, before I go on, I do want to say one thing. If this was the angle we were looking at, that would be absolutely fine. We can still use sine, cosine, and tangent. The only thing that would change is now this is the side that would be opposite. And this is the side that's adjacent because it's next to the angle. And of course, the hypotenuse is still the hypotenuse. So it does depend on which angle you are looking at. But let's go back to the way we had it and let's do an example. So let's say that I knew that this angle, well, this is the angle here. And let's say I knew this was, we'll say a 3, 4, 5 triangle. All right, so if I said, what is the sine of this triangle? Well, the sine is the opposite over the hypotenuse. So the opposite is 3 and the hypotenuse is 5. So the sine would be 3 over 5. If I said, well, what is the cosine of the angle? Well, the cosine is the adjacent, so the one that's right next to the angle over the hypotenuse. So this would be 4 over 5. And I said, well, what is the tangent? The tangent is going to be the opposite over the adjacent, so 3/4. Now, that doesn't tell you an awful lot just on the surface level. All it tells you is the ratio of the sides. But you can actually use this in a minute. I'll show you how you can use it to actually find side lengths. But let's kind of go along with the notes here. So let's say we had a different triangle now. We'll still stay with the, let's say we had a triangle. And let's just, before we can solve this, let's first just figure out on our calculators, how do we calculate these? So if I said, what is the sine of 25? And this is just showing you on your calculator. You're going to go to your calculator. You're going to locate the sine button on your calculator. I don't know if you can see it here. It will just say SIN. Usually right next to it will say cosine, and next to it will say tangent. You do have to make sure your calculator is in degrees. So on this calculator, if I go to mode, you can see if I scroll down, it has radians and degrees is highlighted. So you want to make sure your calculator is in degrees. If you're not getting the right answers, then you might want to Google how to change your calculator from radians to degrees. But if you just hit that sine button and then type in 25 and hit enter, you can get the sine is 0.4226. Again, if you wanted to know what the cosine of 25 is, just again going to use the button cosine 25, and you get 0.9063. And if you wanted to know what the tangent of 25 degrees is, you would just hit tangent 25, and you'd get 0.4663. Again, that's not all that helpful right now as far as determining side lengths, but you need to know how to use your calculator in order to do this. All right, so now let's go ahead and say, all right, how can we use this to actually find the side lengths? So if you have a right triangle and they tell you this is 25 degrees, they tell you this is 3 and this is x. So the first thing you have to decide is, do I want to use the sine, the cosine, or the tangent to solve this? So again, what you know is this is 25 degrees. So opposite your 25 degrees is your 3. Adjacent to your 25 degrees is x, and this is your hypotenuse. Well, I know nothing about the hypotenuse. They haven't labeled it at all, so I'm not going to use the hypotenuse. So now I know one angle and one side. And I know that according to this angle, this side is the opposite and this side is the adjacent. So if I look at my trig ratios, the one that has opposite and adjacent on it is the tangent. So I'm going to set up my equation, right? I know that the tangent of some angle is the opposite over the adjacent. Let's plug in what I know. I know the angle is 25 degrees. So I'm going to say the tangent of 25 degrees is the opposite, which is 3, over the adjacent, which I don't know, which is x. Well, now I have an equation that only has one variable. So let's multiply both sides by x. So I'll get x times the tangent of 25 equals 3. I'm solving this equation like I would solve any other equation. I want to get x alone, so I'm going to divide both sides by the tangent of 25. And now I'm just going to put this in my calculator, 3 divided by the tangent of 25. So I'm going to go to my calculator. I'm going to say 3 divided by, I'm going to have to hit that tangent button, and then 25. And I'll get 6.4 if I round to one decimal place. So now I know that this side length here is 6.4. All right, let's take a look at another example. Let's take a look at example 2. So now in example 2, they give me a triangle that looks like this. And they've given you that this is 74 degrees and the hypotenuse is 5, and they want you to find both x and y. All right. Well, I can't use my Pythagorean theorem because I don't know two sides. It's not a special triangle, so I have to use trig. I have one angle and one side, so that's enough information to use my trig. So based on this angle, this side here is my adjacent side because it's right next to the angle. This side here is my opposite side because it's furthest away from the angle. And remember, across from the 90 is always going to be my hypotenuse. All right. So now I need to solve for both x and y. So I'm going to have to set up two separate equations. So let's solve for x first. So based on x, I have the adjacent and the hypotenuse. Well, if I go back here, which uses the adjacent and the hypotenuse, that's the cosine. So I know the cosine of some angle equals the adjacent over the hypotenuse. Let's plug in what we know. The cosine of 74 equals the adjacent, which I don't know, so I'm going to call that x, over the hypotenuse, which is 5. Remember, the cosine of 74 is just a number, but I'm going to multiply through by 5 to get rid of the fraction. So I've got 5 times the cosine of 74 equals x. I can go to my calculator and just plug this in. 5 times the cosine of 74, and I get 1.4 if I round to 1 decimal. So now I know that this side over here is 1.4. Well, at this stage, I could use my Pythagorean theorem because now I know two sides, so I could use my Pythagorean theorem to find my third side, but let's use trig just to practice it. So now I want to find y, and I could use either side, but because I calculated this one, and this is the one that's given, I'm going to stick with this one. So now I have the opposite and the hypotenuse. So I have to see which one of my trig ratios use opposite and hypotenuse. Well, that will be my sine. So I'm going to set up my equation. The sine of some angle equals the opposite over the hypotenuse. I'm going to plug in what I know. The angle is 74. So I have the sine of 74 equals the opposite, which is y, over the hypotenuse, which is 5. Again, I'm just going to multiply through by 5 to get rid of the fraction. So 5 times the sine of 74 equals y. Just go to my calculator and hit 5 times the sine of 74, and I'll get 4.8. So now I know that this is 4.8. Once again, you can kind of check to make sure your answer makes sense. The hypotenuse should be the longest side, and yes, it is. So that's how you use right triangle trig to find out sides of triangles.